Alright guys, got another video here for quadratics. I want to look at how to graph some stuff, and I'm going to show you guys a little bit of a different approach. So in the last videos, we talked about how to find the axis of symmetry and how to find the vertex. So we still want to start out the same kind of way here. So finding the axis of symmetry would be x equals negative b over 2a. So we'd have, in this case, b would be negative 6, so negative and negative 6 would be positive 6 over 2a, which in this case is 2. And then so that would be 6 over 4, which should reduce down to be 3/2. So our axis of symmetry would be the equation of the line x equals 3 over 2. So if I were to make myself a little sketch of that so far, it looks something like this. 1, 2, 3. So at 1.5 or 3/2, I would have this imaginary dotted line here. It's not actually on the graph. If you were to graph this on a calculator, you wouldn't see the dotted line here. But this is called the axis of symmetry, and it helps you because your line should have symmetry over this imaginary line here, or your parabola should have symmetry. So then to find the vertex, well, we know that it's going to be a point, and the x value has to be on this axis of symmetry. So the x value has to be 3/2. To find the y value, take your equation and plug in 3/2 for the x values. So here, 3/2 squared would be 9 over 4. 6 divided by 2 is 3, times 3 would be 9, plus 9. So we just get y equals 18 over 4, and then these things cancel out. So 18 over 4 appears to be your answer. Technically, you could reduce that, since 2 goes into both those numbers, and make it 9 over 2, which is the same thing as if you're trying to graph this. It might help you to know that's 1.5 comma 4.5. So 1, 2, 3, 4, 5, 6, 7. So at 1.5 comma 4.5, 1, 2, 3, 4.5, we have the vertex of our graph. And we can see from looking at the front of it here, since it's positive, we know that our graph is going to open upward. So from this point, we're going to be going up like this and like this. But we don't really know more points on the graph yet. So one really easy one that will help you out tremendously is to find the y-intercept. We talked about that in the last videos too. Remember that the y-intercept occurs when x is 0. So if you plug in 0 here and here, you're just going to get out positive 9. So we have a y-intercept at 0, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. If I were to reflect across my axis of symmetry, over here at 3, 9, I should have another point. So really, I've got a pretty good start here on my graph. Something nice to note, though. Sorry, I'm thinking here for a second. What we can do is, once you find the vertex, another way to write the equation of this parabola is in vertex form, which is pretty cool stuff. So sorry, I was thinking there for a second. So vertex form is y equals a times x minus h squared plus k. That's the equation of vertex form. So this a here is the same a that we had in standard form. In this case, it would be 2. H is the x value of your vertex. In this case, that would be 3/2. And k is the y value of your vertex. In this case, that would be 9/2. Okay. Alright, so this here is the equation in vertex form. If you've practiced graphing using translations, we know that what's going to happen here is our graph's going to be shifted up 9/2, to the right 3/2, and then we're going to have a vertical stretch of 2 that's going to multiply all of our y values by 2. So let me do some stuff here real quick. So normally from the vertex, if I was just looking at the graph of y equals x squared, for example, the parent function, if you're thinking of translations, well, it would have a point at 0, 0. It would have a point at 1, 1 and negative 1, 1. It would have some points at 2, 4 and negative 2, 4. And at 3, 9 and 4, 16, so on and so forth. So from the vertex, to get to more points on the graph, all you have to do is go over 1 and up 1. So we go to the right 1 and up 1 to find a new point. Or from the vertex, we could also go over 2 and up 4. Okay? So in this equation over here, though, we have a vertical stretch by 2. And what that's going to do is it's going to multiply your y values by 2. So normally you would go over 1 and up 1, but now you're going to go over 1 and up 2. Or normally you would go over 2 and up 4, but now you're going to go over 2 and up 8. Or over 3 and up 9, but now it's over 3 and up 18. Okay, so from your vertex you can go over those amounts and find more points on your graph that way. Alright, so just a little cool thing to note. So from here, from the vertex, we can go over 1, over 2, I guess that would be 2.5, and up 1 to, I guess that would be 5.5. So at 2.5, 5.5, we'd have another point on the graph. And also at 1/2, 5.5, we'd have another point on the graph. Or we could go over 2 and up 8, so over 2 to 3.5, and up 8 from here to, I guess that would be 12.5. There'd be more points on the graph. So just so you get the idea of what you're doing here. It's not as fun when you have nasty fractions, but it still works out the same idea. So you can see our graph would look something like this with the points that we've found so far. So using translations here is another way to graph a quadratic. It helps you tremendously to know what certain numbers will do in your formula. So for example here, if you take any general quadratic equation, you can write it in this form, in this vertex form, if you know what the vertex is. So A in this case will represent things that are a vertical stretch, or sometimes we'll call it a vertical compression if it's making the graph be squished together instead of being stretched out. B, in this case, you won't see a whole lot of B's with quadratics, especially if you're coming this direction. But B, if we had one, would be a horizontal stretch or compression. Instead of stretching the y values out, it would stretch out the x values. H is the x value of your vertex. It also tells you how to shift the graph left and right. And K represents the y value of the vertex, and it tells you how to shift the graph up and down. So just as an example here, normally the graph of a quadratic looks like this. It has your general U shape. It starts at the vertex is at the origin. However, let's say you had y equals x squared minus 4. Well, that's going to take your whole graph and it's going to drop your vertex, the y value, down 4 units. So your graph would look something like this instead. Or if you had y equals x minus 2 squared, well here the negatives, or the 2 here is on the inside. Notice it's a negative, meaning that your vertex, the x value, would be at positive 2. In other words, this is shifting your graph to the right 2. Whereas this was going down 4. So you shift your graph over 2 and then make your parabola. Or you may see somewhere they throw that together all into the same graph. Like, for example, y equals x plus 3 squared minus 2. Well, here we're shifting our graph to the left 3 and down 2. And that's where your vertex is going to go. And then you make your graph. Like something like that. This is just a rough sketch to give you an idea. It's not perfect. You may also see some things where they'll throw numbers in the front. Like, for example, this one. So here, the idea is, well, we're going to translate it to the right 1 and up 4. So over 1, up 1, 2, 3, 4. And let's just say this was a negative 2. That way it'll come out nicer. I can actually open downward. So normally to get more points on the graph, well, you're going to go over 1 and up 1. However, the negative here in the front, when this front term is negative, that's going to be a flip. So your graph's now going to open downward. And it's also, instead of going over 1, up 1, we're going to go over 1 and down 2. Because we're multiplying those y values essentially by negative 2. So instead of going over 1, up 1, we're now going over 1, down 2. So, and instead of going over 2 and up 4, we're now going over 2 and down 8. So over 2 and down 8 would be the next one. And you do the same thing on the other side. So you're going to get a parabola that looks roughly like this, just to give you an idea. So translations are really cool. I have a couple other examples here that I wanted to show you. So for example, if we had y equals x squared minus 8x plus 5. So the first thing we want to do here is try to find the axis of symmetry. That's x equals negative b over 2a. In this example, that would be positive 8 over 2 times 1, which is 4. So your axis would be at x equals 4. Your vertex, well, you'd take that 4 and plug it in for all of the x values and try to solve and find what the y value is that makes that true. So here we'd get 16 minus 32 plus 5, which is negative 16 plus 5, which is negative 11. So your vertex, the x value is 4 that we got from up here. The y value is negative 11. So if I was going to write this in vertex form, notice that a in this case is 1. My h value is 4. My k value is a negative 11, so let's write it as x minus 4 quantity squared minus 11. So if we were going to graph that, I would go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we go to the right, 1, 2, 3, 4. And there would be your vertex. And then to get more points on the graph, since we just have a 1 in front, we're just going over 1 and up 1. And we do that in both directions. So we go over 1 and up 1. Or over 2, starting from the vertex, over 2 and up 1, 2, 3, 4. Same thing over here, over 2 and up 1, 2, 3, 4. And then you can make your graph. If you wanted to make your graph look a little better, you could also go ahead and try to find the y-intercept, which is really easy to do by looking at the standard form equation, which is what this is called. So the standard form is when it's in this form. This is called vertex form down here. Okay, so in standard form, we can see that the y-intercept, if you plug in 0 for x, 0 minus 0 plus 5 would be 5. So 1, 2, 3, 4, 5. My y-intercept is going to be way up there. So somewhere in the middle there, my graph's going to cross the x-axis, but it would look something like that. Okay. One other skill that we'll practice in this unit is talking about the domain and the range. Domain is the x values that are on your graph. And then there's what can we plug in for x in this function up here? What are we allowed to plug in? Well, you really only have to worry about your domain when you have things like square roots or when you have division, because you can't divide by 0 in mathematics. So in this case, we don't have any restrictions on our domain. And if you look at the graph, if we were to graph this on a calculator so we could zoom out, we would see that these lines continue to go on forever in both directions. The domain is everything from negative infinity to positive infinity. And as long as you're graphing parabolas that just go up and down, they open like a U or like an upside down U, the domain will always be negative infinity to positive infinity for a parabola. And that's as long as they're opening up and down. If you are looking at conic sections where you're looking at parabolas where they can open side to side, then your domain would not be all reals. But you don't have to worry about that for just basic quadratics. The range here is the y values. And if you look at your vertex, that will usually help you figure out what your range is. So we know that this y value has to be in the range somewhere. And then depending on if your graph is opening upward or downward, well, if it's opening up, it's going towards positive infinity. So your graph would go from negative 11, including, so we use a square bracket because negative 11 is actually on the graph. It has a point there. And it goes up to positive infinity where we use a parenthesis because infinity is not really a number, it's just a concept. Okay? Let me do one more example here and then I'll stop. So y equals negative x squared plus 3x plus 5. Start off by finding the axis of symmetry. So we'd get negative 3 over 2 times negative 1, which is negative 3 over negative 2, which would be 3/2. Then if I go back and plug that in for y, positive 3/2 plus 5. Well, 3 squared would be 9, and 2 squared is 4, have a negative in the front, plus 9/2 plus 5. Well, that's the same thing as 9/4 plus 18/4 plus 20/4. Okay, 18 minus 9 would be 9/4 plus 20/4 would be 29/4. So, sometimes you get nasty fractions, you just have to get a common denominator and try to work through it. So here our vertex, would be at 3/2, 29/4, which is about 1.5, or it is exactly 1.5, 4 goes into 29 7 1/4 times. So if we were going to go and graph this, well, we know that our vertex is at 1.5, which is also where your axis of symmetry goes. That's the equation x equals 3/2. And then at 7/4, 1, 2, 3, 4, 5, 6, 7. 7/4, we have our vertex. Or sorry, 7 1/4. Okay. If I were to write this real quick in vertex form, notice that a in this case is negative 1. X minus 3/2 squared plus 29/4. So remember that what that negative does is it makes your graph open downward. So we're going to go down 1 and over 1, which would put us at 5/2 and 6 1/4. We'd have a point. Or if we were to go the other way, that would be at 1/2 and 6 1/4. We have a point there as well. Okay, and you can just keep finding points that way. Really quickly, it's easy to find your y-intercept. Remember, that's when x is 0. So if you take your function, you plug in 0 for x, you get out 5. So 0, 5 is the point on the graph. So your parabola would look something like this. It would look better if it was drawn to scale, which mine is not. So that gives you some ideas on ways you can graph. Again, your domain here would be everything from negative infinity to positive infinity. And your range would go from negative infinity, since it's opening downward, up to 29/4 or 7 1/4 if you prefer. So you write it this way, and the 29/4 would get a square bracket, again because we have a point there. So if you have a question, feel free to leave it in the comments below. Otherwise, good luck with your math, and hope you have a wonderful day.